that say heavy?
Heavy.
Oh.
We learned this back in chapter 13, actually back in the thermodynamics chapter way back then, and it may not have made a whole lot of sense, but in 13, we talked about the relationship between Q and K. When Q equals K, the reaction is stopping this at equilibrium. If Q is less than K, that means the reaction's not done yet. It's still going to the right until Q equals K, and then it stops. If Q is greater than K, that means the reaction has gone past its equivalence point, not equivalence point, its equilibrium point, and then it's now having to come back to the left to generate the some of the reactants. Now that's what is going on here with whether a precipitate will form. Remember that all solubility equations are always done the same way. Start with the solid and have it yield whatever the ions are. And if you have Q less than K, that means you're reactant heavy, and it's going to shift to the right and break up and make more products. But if Q is greater than K, that means that you've got a lot of ion, a high ion concentration, and it's too high for equilibrium. It's going to come back this way and make some of that solid. More solid will be made. That's what the question, will a precipitate form, is asking. So we're going to do two examples, and I'm hoping 2 examples. Let's see if we can hustle through this. Okay. The first one I'd like to have you do is number 51 in the book. I don't know if this one is assigned or not. Okay, it's right there in the middle of the page, of the screen. A solution is prepared by mixing 100 ml of that concentration of lead nitrate and 100 ml of that concentration of sodium fluoride. Now, lead ions and fluoride ions, they tend to not be very soluble, so that's going to tend to want to make a precipitate. The question is, will that precipitate form and be visible? Or will the ions, the question really is, are the ions concentrated enough to make a precipitate, or are they dilute enough to just stay dissolved? Notice in this case, there was none of any solid that we started with. So it's kind of like the opposite of what we've been doing. Up till this point, we've taken the solid, put it into water, and watch it dissolve. Now, we've got everything already dissolved. Will it make a solid? See the difference? So the question is, will PbF2 precipitate? The way that we answer these questions, anytime you want to know if a precipitate is going to be formed, write out the chemical equation, and that was what I said in the notes. I said, determine the most likely precipitate. The problem is telling you what the most likely precipitate is in PbF2. So write that out. In its chemical equation, like we've been doing. This is strange because we're not starting with any of this. We're actually starting with lead ions and fluoride ions in 2 solutions being mixed together. But we still want to write this. Be consistent in the way that you write solubility chemical equations. Always write the solid yields the ions. Even though the reaction may have to go left sometimes. That's what would be happening here, is the reaction is trying to go left. So I told you to write what the most common or most likely precipitate would be. And then number 2, find the new concentration. Do you see that a dilution occurred in this problem? I had 100 ml of a lead solution, 100 ml of a fluoride solution, and I put them now together. What happened to the lead? Now it's dispersed more. The fluoride is dispersed more. What is the new concentration of Pb? It was, before we combined these two, it was 0.01 molarity of lead nitrate. That means 0.01 molarity of lead. Yeah? The volume doubled. What's now the new concentration? It's half of what it was before. Right. So before it was 0.01, now it's 0.005. Yes, because no precipitate has been made yet, so that's just now the dilute concentration of Pb. What about the fluoride ion? Same thing's going to happen with the fluoride. Initially, now watch out because they're not the same. This was 10 to the negative second, this is 10 to the negative third. So this fluoride starts at 0.001. It gets cut in half. So now the concentration of fluoride is 0.0005. These are now the dilute concentrations. Yeah, because the volumes are doubling for both. That means the concentrations of them you cut in half. Yep. Okay, will PbF2 precipitate? I'm just going to remind you, this is the abbreviation for precipitate, right? Precipitate forms if Q is greater than K. If Q is greater than K and the reaction shifts that way, we're going to see a solid form. You with me? If Q is less than K, the reaction is going to tend to want to shift to the right, but it can't because there's no solid. So everything just stays dissolved. So can we calculate Q?
Yeah.
Q is calculated the same way as K is calculated. We know that this thing is not right now at equilibrium, or it may be, I guess, if Q is equal to K. Let's calculate Q. Take that times that squared. What do you get? Q
0.3
equals.
times.
Right. Q equals 0.005 times 0.0005 squared. We've just combined these two. We don't know whether this reaction is at equilibrium or not. So we're calculating Q right now because if we know the reaction is at equilibrium, then we find K. The same way, but knowing that that's going to give you K. Right now, I don't know that this is going to give me K. So let's see what this is. 1.3 times 10 to the negative 9th, right?
Yep.
Now, how does Q compare to K?
Plus.
This is Q. This is less than K, which the problem gave us, 4 times 10 to the negative 8. So if Q is less than K, what direction does the reaction tend to shift? If Q is less than K. That means it's reactant heavy, it's going to go that way. So it's not going to make a precipitate. The answer to this one is going to be no. No precipitate forms. Because Q is less than K. It's going to stay to the right. It does not shift itself to the left. If Q is greater than K, that means it's product heavy. It's going to come back and we're going to see solid form. You with me on that? Notice in this one there was no ice table needed. I told you at the beginning of the there's going to be some times when you don't need an ice table. It's now. If you know what the concentrations are, and the question is, will it precipitate form or not, then you don't need an ice table. You just figure out what the concentrations are and find Q. So I have a few problems like this in the homework. You might want to look at the 51, maybe one of them. And now we've just done it. Nabil, what's the matter? Oh, geez, yeah.
Oh, 51's not signed.
The concentration of lead, we had a solution just of lead nitrate, no fluoride, and a solution of sodium fluoride, no lead, right? Those got put together. So notice there was 100 ml of each solution that got put together. So notice for both ions, the volume doubled. When the volume doubled, its concentration gets cut in half.
Oh, okay, I understand.
So it wasn't scientific notation, I don't know if that hung you up, but that number is 0.01. Cut it in half, you get 0.005.
Okay.
That's where that's from, and then that's cut in half too. Okay, Mohammed?
Would it ever be possible to like have two possible precipitates?
No, we're not going to worry about that. No, we'll just have one possible precipitate. Okay.
For the fluoride, I think don't you have to multiply by 2 squared?
No, because this is the concentration. That came from a sodium fluoride solution. 0.005 is the concentration of fluoride ion in the solution. So we have to use it. I know that you need 2 of those for every one of those. I totally get that. And that means that one of these probably is going to still be left over at the end. But you don't double that just because there's a 2 in front of it. Okay? Great question. It's 11:59. Can I show you the next one and we'll see how far we get? Yes? Okay. Thank you.
You said no.
Oh, I thought you said okay. Well, now that you said that, let's just go ahead and do it. All right, so in this case, we again know the KSP of this thing, of aluminum hydroxide, is 2 times 10 to the negative 36. At what pH will a 0.2 molar aluminum solution, so a 0.2 molar is our concentration of aluminum, begin to show precipitation of aluminum hydroxide? So it's asking, at what pH
Oh, the concentration.
is the hydroxide concentration related to pH?
No, it's pH.
Yes.
It is kind of, yeah. I mean,
I said
with
the
2 steps,
pOH.
yes, yep. So if I just call this thing X, can I figure out what that concentration has to be for it to shift left?
Yeah.
Yes.
Yes.
Let's do that.
Okay.
Let's say this. Precipitation forms when Q is greater than K.
Wouldn't that be greater than or equal to? Because that's when it doesn't like start. Wait, what's that?
Greater than or equal to.
No, equal signs just straight.
I normally do greater than or equal to like that.
Oh, okay.
What is that?
That's just.
I'm off. Look. See,
Not
it's
really.
off. Stop it.
Excuses.
With the camera in her hand, she thinks she can say anything.
No.
Okay, so can we find Q?
Absolutely.
Well, I guess in terms of X we can. Q is going to be 0.2 times X, not 3X, it's just X cubed. I know that they react in a 3-to-1 ratio, but that doesn't mean that.
Oh.
Oh, darn it.
We'll start this time.
Just give us all
All right, bye-bye.
Give us all passes. I don't have that many passes.